Hi, this is Ethan with Bride Agrotech. Today we will be talking about electrical conductivity, also known as EC. We will talk about what EC is, how to manage it, and some troubleshooting for common problems with EC. Electrical conductivity, as you might guess, is a measure of how easy electricity can be passed through a solution. This is the easiest way to measure the nutrient concentration of a solution. The reason for that is because most plant nutrients are available as soluble ionic compounds. Ions basically act as an electrolyte in water, and they increase the conductivity of that solution when they are dissolved into solution. When you're adding nutrients to your solution, you are effectively adding ions to that solution, which are increasing the electrical conductivity. So the more nutrient you add, the higher your EC will become. Electrical conductivity is something that we can consistently measure, and that is why it is such an easy system to use for checking your plant's nutrients. So the EC is there to measure how much available nutrient is in your solution. Most hydroponic systems will be running at a range of 1 to 2.5 EC depending on what you want to grow in that system. Seedlings, for example, will take a very low EC because they are sensitive to that nutrient solution. They don't like a lot of salts and you can burn them easily, so they like a low EC somewhere around 1 is what I typically run our setup at. Lettuce is also typically on the low end of the spectrum. I find that I like an EC of about 1.2, 1.4. If you're growing just lettuce, you may have to balance this with other crops that you have in your system. For example, if you are growing herbs like basil, it likes a very high EC, so it likes a lot of nutrients in the solution. It can handle that salt content in solution, and they will prefer up on the higher end of the spectrum, around 2 or even a little bit higher than that. As I said earlier, if you have multiple crops in that system between herbs and lettuce, you're going to have to find a happy medium somewhere in between. So, if you're curious as to what is actually being measured by your nutrient meter when you're measuring EC, it is a unit known as the Siemens. If you're measuring EC specifically, you are measuring millisiemens per centimeter, which is a measure of conductivity through a solution. Now, sometimes you might have meters that will read in conductivity factor, or CF. That's just a scale of 10 above, so you're reading decisiemens per centimeter. So now that you have a basic idea of what EC is, we will talk a little bit about how to monitor and manage your EC. So, in order to measure your electrical conductivity, you will need an EC meter. Oftentimes, these meters are made in conjunction with your pH meter. This is a handheld unit right here that we have made by AutoGrow. If you are using an auto-dosing system, you will already have the pH and the electrical conductivity probe included with that unit as well. What we have here is a meter that reads an EC, electrical conductivity. You will also see meters that will read in parts per million, or total dissolved solids, which is also an expression of parts per million. Those are not ideal for hydroponic usage because parts per million will vary from what region the meter was produced in. Electrical conductivity is always constant across any manufacturer of any meter that reads an EC. It will always be EC from one to the next as long as it's calibrated properly. So these meters that are reading in parts per million, what they are actually doing is first reading the electrical conductivity just like this AutoGrow here is, and then they are sending it through a conversion factor and its little computer software inside there and spitting out an approximation of what parts per million is. The only way to accurately measure parts per million is to actually completely evaporate your solution and weigh what's left. So obviously evaporating off your nutrient solution and weighing the remainder is a very time-consuming process. It's not something you want to be doing all the time to measure your EC. Now, another reason why these parts per million meters are not really the best idea is because depending on the region the meter was manufactured in, one EC will not always be the same parts per million amongst these meters. So you have a US standard, you have an Australian standard, and there is also a European standard for parts per million. For example, a meter produced by Hanna that reads in parts per million, 1 EC is equivalent to 500 parts per million. A meter that is made by UTech that reads in parts per million, 1 EC will be 640 parts per million. A meter that is produced by Truncheon, 1 EC will be 700 parts per million. Are you confused yet? So that, in a nutshell, kids, is why we like to talk in EC. In terms of EC, it is constant. You can talk to anyone across the world about EC, and you are always talking about the same number. You don't have to wonder if this person's from Australia and they're talking about a different conversion factor with the meter that they're using. It's always the same. So when we have customers that call in and they ask me, Ethan, what's wrong? Here's what my EC is, and they give me a number in parts per million, I have to ask them, who made your meter? Now that you know how to monitor your solution with your meter, the next step is actually adjusting your electrical conductivity. So, to adjust your electrical conductivity upwards, if it is too low, you're going to want to use a nutrient solution. If your electrical conductivity is higher than desired, you will want to dilute that with plain water. If your water source has very high EC, i.e. very high total dissolved solids, as you can find in your city's water report, you will want to be using some type of filter like a reverse osmosis filter to help remove those solids from solutions so you have a lower EC starting point with your plain water. And that's why you might want to get a filter if your tap water has a high EC, just because you're adding more nutrients to that solution when you're adding fertilizer. If you're already very high up there, close to your set point with just plain tap water, you're not going to be adding much fertilizer for your plants. You won't be adding much fertilizer to your plants because there's already that high mineral and salt concentration in your water. So if you're adding a lot of nutrients to it, your EC is just going to skyrocket. It's going to be way too high. So you basically have a very limited amount that you can add to your solution because there's these undesirable hard water type minerals in your water. So to summarize, when you're adding your nutrient solutions, you are adding soluble salts to the system there. When you're needing to dilute your solution, adding plain water will lower that concentration of salts and thusly lower your EC. So, if you are in a small hobby-sized system, more than likely you will only have a single part nutrient solution. For this, it is best to refer to the instructions on the back. It may say something like 1 tablespoon per gallon. As always, start on the small side and measure often and increase if you need to. It is a lot easier to add a little bit more nutrient than it is to have to drain solution off of your tank just so you can add water to dilute what you have. Other systems may require a multi-part nutrient solution. Often auto-dosing systems do require multiple components to their nutrient solution. For more info on nutrient solutions, please see our Beginner's Guide to Hydroponics. It is a good idea to measure your electrical conductivity at least daily. If you have an auto-dosing system, it will do this constantly for you. But I would recommend for home systems at least once a day. That is because a number of reasons. When the plants are using that nutrient solution, what they're doing is selective ion uptake. They are taking those nutrients out of solution, which will drop your EC. At the same time, plants are also using up the liquid in that solution. So if they're using up that water faster than they're going through the nutrient solution, your EC will actually rise. You can see a lot of fluctuation there. It's good to check it often, and definitely every time you're adding water or if you're adding nutrients, check your solution and check again once it's had time to circulate through your system. Now we'll talk a little bit about troubleshooting for some common problems that people will have with EC. As mentioned earlier, your starting solution of your tap water, you might have really high total dissolved solids. You may need a filter to get your water into a range where you can actually start adding your hydroponic nutrient to that water. Other common problems that you may experience are reading with a meter that reads in parts per million and not understanding which conversion factor that's using. As we mentioned earlier in this video, That can vary a lot between the manufacturer of the meter, and if you don't know what that relates to in terms of electrical conductivity, you could be taking someone's recommendation and going far above or far below what they actually meant for that solution to be dosed at. Another common problem is adding too much nutrient too fast. As I have said before, it's best to start with small doses and frequently check your solution to make small corrections so you don't overshoot. Another common problem that you will see is not calibrating your meter. Your meter needs to be cleaned and calibrated regularly. If you're using an auto-dosing system where the probes are constantly in solution, I would recommend cleaning and calibrating once per week. If you're using a meter that is handheld and is only in solution once per day for a few minutes, you could probably get away with doing it every 2 to 3 weeks. Electrolytes. It's what plants crave. In a roundabout way, it actually is. While I wouldn't necessarily recommend watering your plants with Gatorade, I hope you've learned today that EC is a measure of the electrical conductivity of the solution. So what you are actually measuring is dissolved ionic salts in the solution. Effectively, you are measuring how much available nutrient has been dissolved into your solution when you measure EC. We really hope you learned a lot from this video today and enjoyed it. If you have any stories about your particular struggles with EC, we would love to hear about it in the comments section below. Also, if we forgot anything, left anything out, or messed up anything, please do not hesitate to let us know. Again, I'm Ethan Walter here with Bright Agrotech. Thank you for watching. Until next time. That's the way the cookie crumbles.